Transient voltage surge suppressors, or TVSS, are designed to protect electrical equipment from damaging voltage spikes. They operate by diverting excess voltage to the ground. Some TVSS manufacturers assert that their products can also reduce energy consumption. However, scientific evidence does not support these claims. Studies have consistently indicated that TVSS systems have no measurable impact on energy usage. Power Gleaner is a specific brand of TVSS system. According to the company's resources, their technology includes capacitors, inductors, and surge suppression devices. These components are designed to filter out voltage spikes and protect equipment from damage. However, no evidence suggests that they can also reduce energy consumption. Customer testimonials can be persuasive, but they are anecdotal evidence and do not provide scientific proof. Customers reporting energy savings from Power Gleaner systems may have experienced other factors contributing to reduced energy consumption, such as changes to appliances, lighting, or heating, ventilation, and air conditioning systems. Power Gleaner has no filings or claims against them, which is a positive sign. However, the absence of regulatory approvals does not guarantee that their technology effectively reduces energy consumption. Based on available evidence, there is no credible scientific support for the claim that TVSS systems, including Power Gleaner, can reduce energy consumption in residential or commercial settings. Consider more energy-efficient solutions if pursuing energy savings, such as energy-efficient appliances, improved insulation, or renewable energy sources. The main function of a TVSS is to protect against transient voltage surges, not to save energy. These surges can be caused by various factors, including lightning strikes, utility switching, and the operation of heavy equipment. When a surge occurs, the TVSS diverts the excess voltage away from sensitive electronic devices, preventing damage. The components typically found in a TVSS, such as capacitors, inductors, and surge suppression devices like metal oxide varistors, are primarily focused on managing and redirecting these voltage spikes. They are not designed to alter the fundamental energy consumption of the devices they protect. Claims of energy savings from TVSS devices often lack rigorous scientific backing. While some manufacturers may present customer testimonials or anecdotal evidence, these accounts are not a substitute for controlled experiments and data analysis. Factors other than the TVSS installation might explain observed reductions in energy consumption. These factors could include changes in usage patterns, equipment upgrades, or improvements in building insulation. Therefore, attributing energy savings solely to the TVSS is often misleading. Regulatory approvals and certifications for TVSS devices typically focus on safety and performance standards related to surge protection, not energy efficiency. The absence of claims or lawsuits against a particular TVSS manufacturer does not automatically validate their energy-saving claims. It simply indicates that the company has not faced legal challenges related to its marketing or product performance. When evaluating energy-saving claims, it is crucial to rely on verifiable data and scientific studies. Look for independent testing and certifications from reputable organizations. These certifications should specifically address energy efficiency, not just surge protection capabilities. Consider alternative energy-efficient solutions instead of relying on TVSS devices for energy savings. Options such as upgrading to energy-efficient appliances, improving insulation, and installing renewable energy systems are proven methods for reducing energy consumption. These solutions directly address the underlying causes of energy waste and offer more reliable and predictable results. Transient voltage surge suppressors are designed to protect electrical equipment, but their ability to reduce energy consumption is not scientifically proven. Energy savings claims should be carefully evaluated, and alternative energy-efficient solutions should be considered for achieving meaningful reductions in energy usage. To reiterate, the core function of a TVSS is to safeguard electrical devices from voltage surges, not to enhance energy efficiency. The fundamental purpose of these devices is to protect sensitive electronics from damage caused by sudden and excessive voltage spikes. These spikes can originate from various sources, including lightning strikes, power grid fluctuations, and the operation of industrial machinery. When a voltage surge occurs, the TVSS acts as a safety valve, diverting the excess voltage away from the protected equipment and channeling it to ground. This prevents the voltage from reaching levels that could damage or destroy electronic components. The internal components of a TVSS, such as metal oxide varistors, silicon avalanche diodes, and gas discharge tubes, are specifically engineered to perform this surge diversion function. These components have a nonlinear resistance characteristic, meaning that their resistance decreases dramatically as the voltage across them increases. When a surge occurs, these components quickly switch to a low resistance state, allowing the surge current to flow through them and to ground. This effectively clamps the voltage at a safe level, protecting the connected equipment. Capacitors and inductors are also sometimes included in TVSS designs to further filter out high-frequency noise and transient voltages. However, their primary role is to improve the surge protection performance of the device, not to reduce energy consumption. The concept of energy savings from TVSS devices is often based on the misconception that these devices can somehow clean up the power supply and make electrical equipment operate more efficiently. However, there is no scientific basis for this claim. The energy consumption of an electrical device is determined by its design and operating characteristics, not by the presence of a TVSS. A TVSS simply protects the device from voltage surges. It does not alter the amount of energy that the device consumes. While some TVSS manufacturers may claim that their products can reduce energy consumption, these claims are typically unsubstantiated and lack rigorous scientific evidence. These claims may be based on anecdotal evidence or flawed testing methodologies. It is important to be skeptical of such claims and to demand verifiable data before making any purchasing decisions. Instead of relying on TVSS devices for energy savings, focus on implementing proven energy efficiency measures. These measures can include upgrading to energy-efficient appliances, improving insulation, sealing air leaks, and using energy-efficient lighting. These measures directly address the root causes of energy waste and can result in significant and measurable energy savings. Furthermore, consider investing in renewable energy systems such as solar panels or wind turbines. These systems can generate clean, sustainable energy and reduce your reliance on fossil fuels. Regulatory approvals and certifications for TVSS devices are primarily focused on safety and performance standards related to surge protection. These standards ensure that the devices can effectively protect against voltage surges and meet certain safety requirements. However, they do not address energy efficiency. Therefore, the presence of regulatory approvals or certifications does not guarantee that a TVSS device can reduce energy consumption. In summary, the primary function of a TVSS is to protect electrical equipment from voltage surges, not to save energy. Energy savings claims from TVSS manufacturers should be viewed with skepticism and should not be a primary factor in your purchasing decision. Focus on implementing proven energy efficiency measures and investing in renewable energy systems to achieve meaningful and sustainable energy savings. The suggestion that a TVSS device can significantly reduce energy consumption is generally not supported by scientific evidence or engineering principles. The core function of a TVSS is to protect electronic equipment from voltage surges, and while this protection is valuable, it doesn't inherently lead to lower energy bills. Voltage surges are brief, high-amplitude spikes in voltage that can damage or destroy sensitive electronic components. TVSS devices work by diverting these surges away from the equipment they are protecting, typically by shunting the excess current to ground. The components within a TVSS, such as metal oxide varistors, are designed to react quickly to these surges, providing a low resistance path to ground when the voltage exceeds a certain threshold. The energy diverted during a surge is typically small, and the duration of the surge is very short, typically measured in microseconds. Therefore, the energy savings associated with preventing damage from surges are negligible compared to the overall energy consumption of the equipment. Some TVSS manufacturers claim that their devices can improve power quality, which in turn can lead to energy savings. However, these claims are often based on a misunderstanding of power quality issues. Power quality refers to the characteristics of the voltage and current in an electrical system, including factors such as voltage sags, voltage swells, harmonics, and transient voltages. While poor power quality can affect the performance and lifespan of electrical equipment, it is not typically a major contributor to energy waste. The most common causes of energy waste are inefficient equipment, poor insulation, and wasteful operating practices. Addressing these issues directly will yield far greater energy savings than trying to improve power quality with a TVSS device. It is also important to note that some TVSS devices can actually consume a small amount of power themselves. These devices typically use a small amount of electricity to monitor the voltage and current in the electrical system. While the power consumption of a single TVSS device is typically very low, the cumulative power consumption of many TVSS devices can be significant, especially in large commercial or industrial facilities. Therefore, it is important to consider the power consumption of the TVSS device itself when evaluating its overall energy efficiency. Regulatory approvals and certifications for TVSS devices primarily focus on safety and performance standards related to surge protection. These standards ensure that the devices can effectively protect against voltage surges and meet certain safety requirements. However, they do not typically address energy efficiency. Therefore, the presence of regulatory approvals or certifications does not guarantee that a TVSS device will save energy. Instead of relying on TVSS devices for energy savings, focus on implementing proven energy efficiency measures such as upgrading to energy-efficient equipment, improving insulation, and adopting energy-efficient operating practices. These measures will provide far greater energy savings than any TVSS device. To provide additional clarification, the basic operation of a transient voltage surge suppressor involves diverting excess voltage. When a surge event occurs, the TVSS provides an alternate path for the surge current to flow, typically to ground, thereby protecting the connected equipment from damage. The key components within a TVSS, such as metal oxide varistors, are designed to quickly and efficiently clamp the voltage, preventing it from exceeding safe levels. The energy dissipated during this clamping process is generally small and has a negligible impact on overall energy consumption. Claims of energy savings often lack a strong scientific foundation and may be based on misinterpretations or flawed testing methodologies. While some manufacturers may suggest that their TVSS devices can improve power factor or reduce harmonic distortion, these effects are typically minimal and do not translate into significant energy savings. Power factor correction primarily addresses the phase difference between voltage and current, which can affect the efficiency of electrical distribution systems. However, the impact of a TVSS on power factor is usually negligible. Similarly, while some TVSS devices may incorporate filters to reduce harmonic distortion, the effect on overall energy consumption is generally small compared to other sources of harmonics such as nonlinear loads. The energy savings associated with preventing equipment damage due to surges are also often overstated. While surge protection is essential for protecting valuable electronic equipment, the energy consumed by damaged equipment is typically a small fraction of the total energy used by a facility. Furthermore, the likelihood of equipment damage due to surges can be reduced through other measures such as proper grounding and wiring practices. It is important to differentiate between the primary function of a TVSS, which is surge protection, and the potential for energy savings. While a TVSS can help to protect equipment from damage and improve power quality to a limited extent, it is not a substitute for comprehensive energy efficiency measures. To achieve meaningful energy savings, it is essential to focus on addressing the root causes of energy waste, such as inefficient equipment, poor insulation, and wasteful operating practices. Regulatory bodies and industry standards typically focus on the surge protection capabilities of TVSS devices, rather than their energy efficiency. These standards ensure that TVSS devices meet certain performance criteria for surge suppression and safety, but they do not provide any assurance that the devices will save energy. Therefore, it is important to rely on independent testing and verification of energy savings claims rather than simply relying on regulatory approvals or certifications. In conclusion, while TVSS devices play an important role in protecting electronic equipment from voltage surges, they are not a primary means of achieving energy savings. Claims of significant energy savings from TVSS devices should be viewed with skepticism, and it is essential to focus on implementing proven energy efficiency measures to reduce overall energy consumption. To emphasize, the principal role of a transient voltage surge suppressor is to safeguard electronic devices against transient voltage surges, and its effectiveness in reducing energy consumption is not scientifically established. Transient voltage surges are abrupt, short-lived spikes in voltage that can potentially harm or destroy sensitive electronic components. TVSS devices function by diverting these surges away from the equipment they are protecting, typically by redirecting the excess current to ground. The components within a TVSS, such as metal oxide varistors, are specifically designed to react swiftly to these surges, providing a low resistance path to ground when the voltage exceeds a predetermined threshold. The energy dissipated during a surge event is typically minimal, and its impact on overall energy consumption is negligible. Claims of energy savings associated with TVSS devices often lack credible scientific support and may be based on misinterpretations or flawed testing methodologies. While some manufacturers may suggest that their TVSS devices can improve power factor or reduce harmonic distortion, the actual impact on energy consumption is usually insignificant. Power factor correction primarily addresses the phase difference between voltage and current, which can affect the efficiency of electrical distribution systems. The contribution of a TVSS to power factor improvement is generally minimal. Similarly, while some TVSS devices may incorporate filters to mitigate harmonic distortion, the resulting reduction in energy consumption is typically small compared to other sources of harmonics. The energy savings attributed to preventing equipment damage due to surges are often exaggerated. While surge protection is crucial for safeguarding valuable electronic equipment, the energy consumed by damaged equipment is typically a small percentage of the total energy usage in a facility. Furthermore, the likelihood of equipment damage due to surges can be mitigated through other preventive measures such as proper grounding and wiring practices. It is important to recognize the distinction between the primary function of a TVSS, which is surge protection, and the potential for energy savings. While a TVSS can help protect equipment and improve power quality to a limited extent, it is not a substitute for comprehensive energy efficiency initiatives. To achieve substantial energy savings, it is essential to address the underlying causes of energy waste, such as inefficient equipment, inadequate installation, and wasteful operating practices. Regulatory bodies and industry standards primarily focus on the surge protection capabilities of TVSS devices rather than the energy efficiency. These standards ensure that TVSS devices meet specific performance criteria for surge suppression and safety, but they do not guarantee energy savings. Therefore, it is prudent to rely on independent testing and verification of energy savings claims rather than solely relying on regulatory approvals or certifications. In summary, while TVSS devices are vital for protecting electronic equipment from voltage surges, they are not a primary solution for achieving energy savings. Claims of significant energy savings from TVSS devices should be viewed with caution, and it is essential to prioritize proven energy efficiency strategies to reduce overall energy consumption.